Welcome to the afternoon. One of the things we weren't supposed to do was put a cognitive lesson in front of you in the afternoon, but we're going to do just that. We like to challenge ourselves, and we're going to challenge you this afternoon as well. Part of the light show was just to sort of point out that electricity is all around us. You have it in the computers, you have it in your home, you have it in your car. It's there and everywhere. And so this afternoon we're going to introduce you guys to Ohm's Law, but more importantly we're going to get you to teach you how to solve for Ohm's Law given two of the items that we have there. So really we want you to learn how to add, or not add, no adding, multiply and divide a few numbers. So let me just ask, has anybody heard of Ohm's Law? So you're Ohm's Law because you're in the library and see books, or?
No, because I have terrible memories of high school.
So Ohm's Law is low on your list of things to know.
Extremely.
Okay. Anybody else? No? Anybody?
I heard about it, but I don't remember what it is.
Okay.
Yeah, same.
The other thing is, but I'm going to guess, and of course this is making big assumptions, but I believe since most of us probably passed, went through grade school, we know how to multiply and divide, right? Multiplication, 1 times 2, 2. Anyway, that's a simple step. If you do not know how to multiply and divide, just go along with the class, and at the end of the class we can talk about tutoring and math or something else. So what we'll do is work through the class in that we'll introduce the Ohm's Law. You'll know what that is. And then Andrew is going to demonstrate a few of the formulas. He's going to work with you. Or actually we're going to introduce one formula or one question. And we'll work through that question together as a group. Then he's going to introduce a tool that you can use to actually help yourself work through that equation. And then after that, we will give you a quiz. And it'll be a self-assessment quiz, but we'll let you do the quiz on your own. And at the end, we'll see how well you did. And
if you don't pass, we have to stay till the end on Friday.
So there's a big incentive that pass. There's problems. Actually, one of the things about Ohm's Law and the things that sort of might encourage you is that if you can get this basic concept down, you can be an electrician or electrical engineer or electronics engineer. I mean, you could do anything in the world. So just a simple little process will help you for the rest of your life. And maybe give you options that you never had before. With that, so is there any questions about what we're doing this afternoon? No? Are we okay? Let me introduce you to Ohm's Law. Ta-da! There it is. So Ohm's Law is voltage times current times, or voltage is equal to current times resistance. That's all it is. It's a formula that is used in electricity to determine those three things: what the voltage is in the circuit, or what the current is in the circuit, or what the resistance is in the circuit, if you have the other two items. So that's Ohm's Law. Pretty straightforward. I don't think you're going to have any problems with it, but Andrew's going to show you how easy it is.
Current times what?
Current times resistance.
Oh, resistance.
Yeah, which is the R for resistance down here, which is spelled kind of funny.
Okay.
So we'll start off with one question, and we'll all work together. We'll do it out loud, and people can shout out answers or whatever, and we'll go on the board and we'll work through it. Yeah, so we'll just start. So let's say we have an electric car, and the car uses 40 amps. And it has a resistance of 4 ohms. So using the formula that we have there, V equals I times R. So if we plug the numbers in here, if you're looking at the I, which you see over there is the current, is amps, is 40 times R, which is resistance, 4. So the volts would equal 160.
You now know Ohm's law.
That's Ohm's law, right there. So a nice little tool when you start rotating around. So if you're looking for resistance or anything like that, a little tool that we use in the field that helps quite a bit is the triangle. So when we use this triangle, basically whatever one you're looking for, you just cover up the letter. So if you're looking for resistance, you can cover up the R. And that is amps or current, or volts divided by amps. If you're looking for volts, you cover up the V, and it's I times R. So that's basically what we did here. You understand the triangle? Not too bad? Okay. We'll do one more, and we can try using the triangle on it this time. And I won't give you as much help. We'll just kind of go through the class, and you guys can see if you can figure out the answer. So, we have a house, and it is 120 volts. And it is using 40 amps. So, and using the triangle here, does anyone have the answer?
3.
3. So what you're looking for, what are we looking for the resistance, so you're covering up the R. So volts times amps is 120 divided by 40 is 3. So you have 3 ohms. So R would equal 3 ohms. Pretty simple so far? Any questions? Anyone have any concerns or anything?
Anybody? No? What if we do a quiz? You all up for a quiz? Ready to go? We should put them down. We should have a timed quiz. The thing about quizzes is it's more a self-assessment to see if in fact you have actually gotten the idea, or whether or not you have to spend a bit more time studying to get the point. Because usually these things, will end up being on an exam somewhere. So if you know it, you do it. So me and Andrew will be around here. We'll if you got any questions, we will be more than happy to help out.
Yes?
Peace.
Peace. Oh, okay. I thought you were asking us a question. I'm like, are you really trying to figure these out?
If you're having problems, that triangle really works. You can actually write that on a piece of paper. Stick it on there. Use that little thumb to cover up what you're trying to find. Don't worry if you don't get it, because we didn't really get into the old resistance and current and what they really
It can be confusing.
are. So don't worry about it if it's not exactly.
Let's see, a few people are finishing up.
Yeah.
So why don't we quickly go over the answers and see who can self-mark your own quiz.
Actually, why don't we just ask? Did anybody get an answer for number 1? Yes?
8.
8? Close.
Isn't it 240 divided by 30?
Oh, it is 8, isn't it?
Yes.
Yes. My math skills are rusty. Yes. Thank you, Michelle. Yes.
I trumped you.
Yes, you did. Very good.
Yeah, don't show them the answer.
8.
So there's the answer sheet for
I should have used the calculator. Okay. How about number 2? Did anybody get number 2? 12. Yes. And how about number 3?
2.
2 amps. There we go.
Great.
So, how many people got 3 out of 3? Oh, good. That's good. How many? Everybody got 2, or anybody 2? we won't worry about the rest of it. We'll have a successful bell curve here that's working out well for us. Anyway, just to point out that this is actually used, this formula is used in the field of electricity. And it's important for electrical apprentices and people coming into it to know this formula well. Of course, they would have more knowledge of the actual what resistance is and what current is, but for our afternoon 10-minute session, we're happy to share with you the ways of actually calculating a few of them out. Thank you very much.
Thank you guys.